Okay, this is the last section, and it is still using the trig ratios, trig functions, but it deals with vectors. We did vectors before.
Oh my god! Cholesterol. It gives you all your daily nutrients.
Okay. We did the vectors. Remember, you have a.
Oh, okay.
Not right now.
Not right now? You don't want? Okay, yeah.
A vector has its initial point. It's where it starts, and its terminal point, where it ends. It ends where the arrow is. So, like, remember when we named vectors, you put the initial point first, and then they're not always alphabetical. Where it ends has to be second, and then the vector symbols like that. Do you remember doing that?
Yeah.
And then we had to name its component form. How do you get from A to B? So remember, this is opposite of slope. Slope is rise over run. Vector is the way slope should have been. Yeah, you go, how do you get from one to the other? You go right 1, 2, 3, 4, and up 2. Okay? Remember doing that? So that's part of, we're doing this again. You're naming vectors and writing its component form. Okay? But then added to it now is we're going to find the magnitude and direction. I don't know if anyone remembers this from Despicable Me.
Yeah. Oh my gosh.
Vector. Vector was a criminal. And when he introduced himself as Vector,
Oh my god, don't even, no.
he introduced himself as Vector, and they say, why or something? He said, because I have magnitude and direction.
Oh, yeah.
Yeah.
Yeah, that's how I'm going to remember it, with little demons running around, yes.
Okay.
Demons?
Magnitude. All the magnitude is now, in word problems, a lot of times it has to do with your speed, how fast you're going. Now, in a problem like this, the magnitude is just the length of the vector. When we graph these, it involves speed, miles and hours, so the length turns out to be miles per hour. Okay? So when they ask for magnitude, you're just going to find how far it is from A to B. So do you remember how to find out the length of a segment on a graph?
Oh, I hated that.
Distance formula. Okay?
How about we not?
Well, there's a shortcut for these. I'll show you when we get to it. You don't always have to use the distance formula because of this right here. Well, I'll just show you now since we got the drawing up here. This distance is 4. This distance is 2. What kind of figure does this make right there?
Triangle.
So, can you find the hypotenuse?
Yes.
It's 4 squared plus 2 squared, square rooted.
Oh, yeah.
Okay? That's all the distance formula is if you take x minus x, it'll turn out to be 4. Y minus y will turn out to be the up and down. And then you square them. So all we do is the Pythagorean theorem using the component form. This is always a leg, and this is the other leg every single time. So it's leg squared plus leg squared, square rooted. Yep, that's the distance formula. The direction, we're going to do the direction tomorrow. We're just going to do the naming it and finding the magnitude today. But direction is formed with the horizon, like airplanes flying vectors because they can fly in a straight line. So if they take off from airport A and they end up at airport B, they're flying like this. The direction is the angle you take formed with the horizon. The horizon is straight out, so this would be the angle taken And then it's also going down, which is south, and to the right, which is east. So you'd find what this angle is, and then it'd be southeast. But again, we'll do that tomorrow. Today, we're just gonna do the magnitude. Okay. Equal vectors is just what it sounds like. They're exactly the same. Parallel vectors, just what it sounds. They wouldn't intersect. Sum of vectors, you're just adding them together. Now this is super easy. If you've got a vector, like say AB is 3, 5, and vector XP is 2, -1. If they added these together, all you do is you add the x's and add the y's. So the sum of AB plus XP is 5, 4. Okay? So adding vectors or subtracting, same thing.
Hey! You.
What the heck are you doing?
What's the point for this?
On your shirt.
Thank you.
Okay,
Sorry, I interrupted.
so in this one, here they've got P and Q are the initial and terminal points. So P is the initial. When you draw this then, when we do take the test later this week, you're gonna have a point just like, or a problem just like this. You're gonna be given 2 points. You have to graph them. P is left 4, up 3. Q is 2 over 1 down. And then you draw in the vector like that. Okay? We're also going to need to name it. This is just vector PQ. The component form of it is, how do you get from P to Q? I got to go over 1, 2, 3, 4, 5, 6. And then down 4, so it's -4. Okay? Now, to find its magnitude, if you have the graph, you can use the Pythagorean theorem. If you're just given 2 points, you use the distance formula. So the distance formula is x minus x. -4 take away 2 is -6 squared. Plus y minus y. 3 take away -1 is 4 squared. Square rooted. Now,
If you have a negative, it doesn't matter.
right. If you got a negative in it, it's going to turn positive, so just disregard it. Because depending on what calculator it uses, it could give you an error. All of these we rounded in nearest tenth. So that's 52 square rooted. It's 7.2. So the magnitude is 7.2. Okay? So here's how you name it. Here's the component form, and the magnitude is 7.2. That's what we're going to be doing today.
So we have to find both those things.
Yeah. So here we've got, this is what most word problems are. The vector CD describes the velocity. Velocity, how fast it's going, of a moving hot air balloon. The scale on each axis is in miles per hour, so this is 5. They go by 5s. So to find the speed and magnitude are the same thing, which is the distance. So again, if you have the graph, like here, I could have just did the Pythagorean theorem. Instead of doing the distance formula, you get the same answer. So since we have a graph, you just make a right triangle. These go by 5s now. This is what you got to remember on these. And on the,
25.
yep, 5, 10, 15, 20, 25, and that's 20. So the speed is 20 squared plus 25 squared, square rooted.
32.
32 even? No.
Oh, 32.01.
Oh yeah, so it just rounds to 32.
Yeah.
So it'd be 32, and it says that it's in miles per hour. Now, we're not going to do the direction yet, because that's what we'll do tomorrow. Okay? It's going up, so that'd be north. And it's going right, so that would be east, northeast, but then we'd have to find this angle too, by using tangent inverse.
Oh, that was.
Who are your arrows?
Okay,
Oh,
I don't think we're doing the adding yet either, so.
No assignments?
Yep, we'll do that tomorrow. So, yeah, today we are just doing the
I know.
magnitude.